Hello and welcome to Math with Mrs. Becker. Today in Algebra 2, we are going to be looking at section 6.4 in the text where we factor polynomials. It says, recall that if a number is divided by any of its factors, the remainder is 0. So what that tells you is that if you are dividing something by its factor, you will not have a remainder. It divides perfectly. So knowing this, we can use our skills from section 6.3 where we were dividing polynomials, and we can determine if one polynomial is a factor of the other. We know that it is a factor if the remainder is a 0. So let's try some examples. Okay, this says determine whether the given polynomial is a factor of the polynomial. Okay, so you want to know if this is a factor of this. I can use synthetic division, because this is just x plus or minus a number. Remember from 6.3, the formula was a negative. Okay, so what that means is that in the box, we would be putting a negative 1. 2x's, 1x, no x's. I do not have to add in any zeros. Reminder, with synthetic division, you only use the coefficients. Carry down the first term, which is a 1. 1 times negative 1 is negative 1. Negative 3 plus negative 1 is negative 4. Negative 4 times negative 1 is positive 4. 1 plus 4 is 5. So this has a remainder of 5. So no, it is not a factor. It did not divide perfectly. Let's do another one. Again, I can do synthetic division because the formula for synthetic division is a minus. I need to realize that this is x minus a negative 2. Negative 2 will go in the box. 4x's, 3x's, 1x, no x's. You cannot do that. You can't skip values of x. It will be 4, 3, 2, 1, 0. 3 is in front of x to the power of 4. 6 is in front of x cubed. 0x squared, negative 5x, and negative 10. Carry down the first term. 3 times negative 2 is negative 6. 6 plus negative 6 is 0. 0 times negative 2 is 0. 0 plus 0 is 0. 0 times negative 2 is 0. Negative 5 plus 0 is negative 5. Negative 5 times negative 2 is positive 10. Negative 10 and a positive 10 make 0. Remember on the last section when I said it's possible that when you're doing synthetic division, you'll get like a big ton of zeros in one cluster? That is what happened here. Okay, but again, if we are looking to see if something is a factor, the only thing that really matters is the remainder. If you have a remainder like we did here, it's not a factor. This has a remainder of 0. That means it divides perfectly. So yes, x plus 2 is a factor of 3x to the power of 4 plus 6x cubed minus 5x minus 10. Okay, let's do a couple more. If I want to know if this is a factor of this, is x plus 2 a factor of x or 4x squared minus 2x plus 5? I would have to have a negative 2 in the box, 2x's, 1x, no x's. So this time I did not have to add in any zeros. Carry down the 4. 4 times negative 2 is negative 8. Negative 2 plus a negative 8 is a negative 10. Negative 10 times negative 2 is positive 20. 5 plus 20 is 25. So this gives us a remainder of 25. So no, it is not a factor. Now for D, notice I gave you a little bit more room. That's because we can't use synthetic division for example D. Synthetic division, you have to have a variable all by itself. You can't have a number in the front. You can't have an exponent. It has to be two terms. In this case, we have a number in front of x. So in order to see if this is a factor, I need to go back to long division. 4x's, 3x's, 2x's, 1x, no x's. So I don't have to add in any zeros. It is in the correct order. So after this, we have reviewed all of section 6.3 because we did both long division and synthetic division. Kind of cool. I have 3x. I need to have 3x to the power of 4. So you ask yourself, what are you missing? I am missing 3x's. So x cubed times 3x is 3x to the power of 4. X cubed times negative 6 is negative 6x cubed. Now remember, in order to cancel this first term, what you need to do is change all the signs of the second row. So this would become a negative, this would need to become a positive. These two are opposite, so they cancel. These two are also opposite, so they cancel. I have two terms on the outside, so you always want to make sure that you're looking at least two terms. So for that reason, because I crossed off both terms, I'm bringing down two terms. Now 3x needs to become 6x squared. To turn 3x into 6x squared, I need a 2x. 2x times 3x is 6x squared. 2x times negative 6 is negative 12x. In order to cancel the first term, this becomes a negative, this becomes a positive. Those two are opposites, they cancel. 3x plus 12x makes 15x. Carry down the next term. I need 3x to become 15x. To turn 3x into 15x, you need to multiply by 5. 5 times 3x is 15x. 5 times negative 6 is negative 30. In order to cancel the first term, you take the whole second row, change the signs. This is negative, this is positive. This cancels, this cancels. There's nothing left to bring down. I do not have a remainder. So yes, 3x minus 6 is a factor of the other polynomial. So that's the first part of today's lesson. Just being able to determine if one polynomial is a factor of the other. You know it's a factor if the remainder is 0. Now we're going to move into factoring, okay? We are already familiar with methods of factoring for quadratics. Remember in chapter 5, we went ahead and we factored using the multiply add method, and we did grouping, and we did difference of squares, all of those things. Now we're going to take those methods and go to higher degrees. Remember, when you are factoring and you have 4 terms, the process is called grouping. So we are going to practice a few examples of how you factor by grouping. Now it's called grouping because what you do is you put parentheses around the first 2 terms, parentheses around the second 2 terms. Okay, you are creating groups. Now you divide out what they have in common. If I look at the first set of parentheses, both of those terms have 2 x's. So I can divide out 2 x's. That would leave me with x minus 1. Now for grouping, this needs to become this. So often the easiest thing is to look at just the first terms. I need negative 25x to become just an x. That means I need to divide out the negative 25. The negative cancels, the 25 cancels, I have x. Positive divided by a negative is a negative. 25 divided by 25 is a 1. This matches this. And with grouping, it's kind of nice because that's like a checkpoint. You know without a doubt you did this correct. Whatever you were able to divide out. So for us, it was an x squared and a negative 25. They come together to form one group. The binomials that match, they are your second group. So even though you have them twice in the work, in the final answer, you only see it once, okay? Now you have to get in the habit of looking and saying, okay, can I factor again? So we did the grouping method. This is 2 terms with a minus in between. These are both perfect squares. If I take the square root of x squared, that's x. If I take the square root of 25, that's 5. So I can do the difference of squares that says if you can take the square root of the first term and the last term, those 2 terms, you take the solution and you add it, so x plus 5, and you subtract it. The x minus 1, I could not do anything further. That is factored. So we did grouping and the difference of squares. Okay, we're going to do a couple more just to make sure we've got it. If you have 1, 2, 3, 4 terms. If you have 4 terms, you do the grouping method, parentheses around the first 2 terms, parentheses around the second 2 terms. If I look at these 2 terms, what they have in common is x squared. I would have x minus 2 remaining. I need this to become x minus 2. So I'll look at the first term. If I have negative 9x, and I need to have just an x, I need to get rid of the negative 9. Negative cancels, 9 cancels, so I'd have x. Positive divided by a negative is a negative. 18 divided by 9 is 2. x minus 2 and x minus 2 matches. So we know that we did this correct. Whatever you took out, in our case it's an x squared minus 9, that comes together and forms a group. What you had in common, that is the second group. But now that we're working with higher exponents, often you'll have to use 2 methods of factoring, sometimes even 3 before you're done. So you want to be in the habit of looking and saying, okay, is there more I can do? And there is. I can take those 2 terms and I can take the square root. The square root of x squared is x. The square root of 9 is 3. The difference of squares says that I would take the x and the 3 and I'd add them and subtract them. And don't forget that we still have our x minus 2. Okay, last one like this, and then we're going to talk about a whole new factoring technique that you've never done before. If I have 4 terms, to start factoring, it's always grouping. If I look here, both of those terms contain 2 x's, so I can take out an x squared. I would have 2x plus x squared divided by x squared is 1. Okay, if everything crosses off, it's a value of 1. I need this to become this. If I want 8x to match a 2x, I need to divide it by 4. 8x divided by 4 is 2x. 4 divided by 4 is 1. This matches, so we know that we did this correct. What we took out is x squared and a positive 4. What they had in common is x squared plus 1. Now this time we are done. You cannot do the difference of squares with x squared plus 4 because this is plus. That process that we just used in the last 2 examples where you took the square root, that's called the difference of squares. You have to have a difference, meaning it must be a minus sign in between. All right, new factoring technique. There is a rule, and it's called the sum of 2 cubes as well as the difference of 2 cubes. So this one works if there is a plus sign or a minus sign in between. What occurs if you have 2 terms, whether you're adding or subtracting, and you can take the cubic root of both terms and it matches, then you can use one of these methods. The cubic root of a cubed is a. The cubic root of b cubed is b. Then you guys, you simply just fill it into the formula. Okay, so whatever the cubic root of the first term is, that is a. You'll notice in the formula there's places where they tell you a. So you would fill that value in. The cubic root of the second term is b. You would just fill that into the formula where the b's are. Let's go ahead and look at an example, okay? Step 1, though, if you are factoring, you always want to divide out what they have in common. If I look at 4x to the power of 4 plus 108x, I can divide out 4x. If you have something in common, you always have to do that first no matter what. I would have 3 x's remaining. 108 divided by 4 is 27. There was an x, I took it out. Okay, so that's step 1, divide out the greatest common factor. Here is our sum of cubes. A cubic root means what value times itself 3 times gets you to x cubed. Well, that's an x, because x times x times x is x cubed. The cubic root of 27. What number to the power of 3 gets you to 27? Well, that's a 3. So a is x, because it's the cubic root of the first term. B is 3, because it's the cubic term of the second term. Here is the formula. So I have 4x. Okay, I'm going to back this up a little bit so we can look at them at the same time. I have the 4x because we had to take that out. So that's still part of the problem. Now, because it was a plus sign in between, that's why I'm following this formula. Take a plus b in parentheses. A is x, b is 3. Now open a second set of parentheses. Take the a value and square it. A is x, so I have x squared. Minus sign. Take a times b. X times 3 is 3x. Plus sign. Take b and square it. b is 3. 3 squared is 9. You're done. So that's how the sum and difference of cubes work. Okay, let's do another one. This time, there's nothing in common. I can't divide 125 and 8 by the same value. They are both perfect cubes. So if I take the cubic root of 125, what number to the power of 3 gets you to 125? That's a 5. The cubic root of d cubed is D. So A, whenever you see A, you're using 5D. The cubic root of 8, what number times itself 3 times? Or what number to the power of 3 gets you to an 8? That's a 2. So 2 is B. Now this time it's a minus sign in between. So I have to use this formula. So in parentheses, A minus B. So 5D minus 2. Open a second set of parentheses. Take the A value and square it. Well, if A is 5D, if you square something that has a number and a variable, remember you have to square both values. So 5 squared becomes 25. D squared becomes D squared. Plus sign, and I'm getting that right from the formula. Take A times B. 5D times 2, well, that's 10D. Plus sign, B squared. 2 squared is 4. There's your formula, and you're done. Okay, 2 more. And I'm just going to keep the formulas right here as I flip this over so we can refer to them. Okay, again, nothing that they have in common. Okay, that I can't divide anything out. The cubic root of 8 is 2. The cubic root of z to the power of 6 is z squared, because z squared times z squared times z squared, if you added up those exponents, you would end up with 6. So A is 2, B is z squared. Don't worry about the order. You're just learning a new technique. This is a plus sign in between, so I'm using the sum of 2 cubes. It says to take A plus B in parentheses. So 2 plus z squared in parentheses. Open a second set of parentheses. Take the A value and square it. Well, A is 2. 2 squared is 4. Minus sign. Take A times B. 2 times z squared is 2z squared. Plus sign. Take the B value and square it. If I take z squared and I square it, I would have an exponent inside and outside. 2 times 2 would give me a 4. We are done. That's it. Okay, that's the sum of cubes. Last one. Again, step 1, if you are asked to factor, you always have to look and see if there's something in common that you can divide out. 2 and 16 are both divisible by 2. If the first term has 5 x's and this term has 2 x's, I can remove 2 x's. So to figure out what I have left, I divide each number by 2 and I remove 2 x's. The 2's cancel. If I have 5 x's and I take 2 out, I'm down to 3. Minus 16 divided by 2 is 8. I had x squared, I took them out. Okay, so this is still part of the answer. Okay, so we have to just make sure that that kind of carries on throughout the process. This is the difference of cubes. The cubic root of x cubed is x. The cubic root of 8 is 2. So A is x, B is 2. It's a minus sign in between, so we are looking at the difference of 2 cubes. 2x squared goes first. Okay, now the difference of cubes, take A minus B in parentheses. A is x, B is 2. So A minus 2 or x minus 2 in parentheses. Now open a second set of parentheses, take A squared. A is x, so it's x squared. Plus sign. Take A times B. X times 2 is 2x. Plus sign. Take B squared. B is 2. 2 squared is 4, and you're done. Last skill for the day. If you are looking at a graph, you can actually factor something by identifying the zeros. So check this out. If you graph this, this is what the problem would look like. Your function, if you were to look at Desmos, okay? Your zeros help you to factor. So you would start off by saying, okay, where are your zeros? It's on the x-axis, so it's x equals negative 5, x equals negative 2, x equals positive 1. Well, now those are solutions. If you want it factored, you want to move the number over to the variable. So here, I would add 5 over to the x. Here, I would add 2 over to the x. Here, I would have to minus the 1. That would be factored form. So you identify the zeros. You have to state it as an equation, because if you're looking at it that way, that's what you're doing. Now to write it as a factor, you move the solution over to the other side of the equation with the variable, then you can write it in the parentheses. Let's look at one more of those just to make sure we've got it. So again, if you were to graph that polynomial function, this is what it would look like. If you want it in factored form, identify the zeros. X equals, it touches a positive 1, so x equals 1. X equals 3, x equals 4. But if you want it in factored form, you need to move the numbers over to the variable. So to move the 1 over to the x, I would have to minus it to the other side. To move the 3 over to the x, I would have to minus it to the other side. Same thing with the 4. Now it's in factored form. That is all of section 6.4. Your assignment is in the book. You will turn to page 433 and complete numbers 1 through 16. I hope you had a great day, and I'll talk to you soon.